Well, welcome to class, learners. With us today, we want to discuss swords. So, sword is a very important topic in mathematics, even in further maths. So, if you are planning to write exams, GC, WAEC, Post-UTME, and Co., this is the best channel to be in. If this is the first time of coming across this channel, kindly do well to hit the plus sign or follow for more, subscribe. Please encourage me. The first thing we want to discuss is, let's talk about what swords are. So what is a sword? Sword are simply a rational number that cannot be simplified. Irrational numbers that cannot be simplified. So we can call those numbers odd numbers here that cannot be simplified. So example of sword is if I have 2. This is a sword. It doesn't have an whole number. That's what we mean by the word cannot be simplified. It doesn't have whole numbers. This is a sword. Next up, this is a sword. This is 1. This is 2. This is a sword. This is a sword. This is a sword. All of these numbers cannot be simplified, meaning they don't have an whole number as their answers. So because these are called swords, it is very important you understand why they are swords. So they cannot be simplified. But note that these are not swords. If you have this and you're having this is not called a sword. This is not a sword. This is not a sword. This is not a sword. So these are not sword because they have whole numbers as their answer. They are not called a rational number. So a rational number are simply, you can put in bracket, odd numbers, which are these, and they are also called swords. So this is what we know about the definition of swords. Next thing to note is, let's talk about the rules. The rules of sword. There are laws that govern sword. There are laws that govern swords. So number 1, we have multiplication law. The first one here is called multiplication law. In this case, we are saying that when we have 2 or 3 sets with the multiplication sign, you can multiply all of them. This is what we say. If you have A here and B here, first, you can make this root to be 1 and then combine the both sets inside, or the both element inside. You can do this, which is correct. Yes, you can do this like this. Or if you have it like this from the beginning, like this, from the beginning like this, you can express them like this. Yes, you can. This is a very correct fact. Yes, it can. So please don't forget, for multiplication is that we can combine them together. That means we can multiply them together. We can make the root 1 and then multiply them together. That is what the rules talk about. Next number 2, we have the division rule. Division rule. For this division rule, we are saying that it also works almost like this. Almost like this. So when you have this, A all over this. So we are saying that you can also make the root 1. Yes, the root can be expressed as 1, and then you can proceed to solve. So I can express it as this. So A over B. This is correct. So that means I can express multiplication like this or multiplication like this. It is correct. That's what we are saying. They are all correct going further. They are all correct going further. So For this division rule, let me give you one example for this division rule here. If I have 12 over root 3 like this, yes, I can. The first step I would take is to bring the both number, making the root 1 like this. Then this takes care of this. Yes, 4. So what is the root of this? My answer is 2. Yeah, this is correct. Yes, you can do it like this. Make the root 1, then you divide, and then you proceed to getting your answer. Yes, this is correct. For this one, if I have it like this, 3 and 6, I can make the root 1. So this is 3 times 6 here, and then that will give us, okay, let me use 2 and 3. Just let me use 2 and 3. So this will give us root 6, like this. So this is also part of an irrational number. Yes, an irrational number. So this is how it works. Number 3 rules. Number 3. Number 3 is this addition. Addition rule. So there is some things you need to know about addition rule. The rule is this. You cannot have this. Let's say you have A here plus B here, and then you now state it like this. This can be A plus B. This is wrong. It's completely wrong. It doesn't work like that. That means these two cannot be added to give this. It doesn't work that way. It doesn't work that way. What we are saying in this case is, anytime I have, look at this, if I have 3 here and then I have 2 here, you can't make them like this. You can't say this is 3 plus 2 and then you get 5. This is not correct. This rule is not applicable here. So whenever you are solving for subtraction, this is also the same thing for subtraction. For subtraction and addition, these things are not correct. Let's say if here is minus, let's say here is minus, you can't make the root 1 and make it minus. It doesn't work that way. So for plus and minus, this rule is not applied. It is only applicable where you have same roots. Let's say this is A and A. You can now have A plus A. You make the root 1 and have A plus A. But if you have different roots, you cannot apply it like this, making the root 1 and having it like this. It cannot work. It doesn't work that way. It doesn't work that way. So for plus and for minus, take note of this very critically. So let's start traveling deeper in Surds. Hope all of these things are noted. So let's start traveling deeper in Surds. Let's start traveling deeper in Surds. So let's talk about simplification of Surds. So we want to simplify Surds now. Simplification of Surds. Let's talk about that. So number 1, we are asked to simplify. Let's take 4. Okay, let's take 12. We're asked to simplify this. Now, whenever you are asked to simplify Surds, just one root, there are things you have to know. 2 things. First, we are going to look for a number that is a perfect square number of that same number, 12, and also the odd number, meaning that there is a relationship between a perfect square number and an odd number. So those perfect square are those numbers that when you find their square root, they will give you whole numbers. Why those irrational numbers are those numbers that don't have whole numbers? I say that again. Those perfect square are numbers that when you say find root 4, what's the square root of 4? Is 2. That's an whole number. What's the square root of 9? Is 3. That's an whole number. What's the square root of 16? Is 4. That's an whole number. But When you now check the root of 2, you discover that it will give you decimal. So that is not an whole number. So we are saying that from this place, you are expected to bring out two things, the perfect square number and also the odd number. That's what we are talking of. So let's start with this. So how do we work on this? First, my advice is this. Take this somewhere for the beginners. Take this somewhere. Take this 12 somewhere and start dividing with the smallest number. Smallest number that can divide this. So obviously it's 2. So 2 can go here is 6. 2 can still go here is 3. 2 cannot go here, but 3 can go here. So that will give us 1. Now, since I know of these factors here, what do I do next? I am now going to think of how to produce a perfect square number from them, and also the odd numbers. So obviously, for them 2 times 2 here, when you combine this, when you combine these two, when you combine 2 times 2 here, remember 2 times 2 will give me 4. This is a perfect square number. So this is the only number that is remaining out of this factor. So that means when I multiply 4 times 3, I'm going to have it as 12. So it's giving me this back, whereby I've been able to produce a perfect square number and also an odd number. That is the aim. So from here, I will now break this one down into that 4 and 3. So I'll put it like this: 4 times 3. So remember what I told you, that as it is like this now, you can split it if you want. You can split it like this. So this becomes this, and this becomes this. So I can now find the square root here. What will be my square root here? My square root here is 2, then times the root of this. So obviously, you cannot leave them like this. You have to take away this root, this multiplication sign, by multiplying this, not the root, please. You cannot use this to multiply this. Reason is because this 2 is not inside a root. Yes, so this can only affect this one inside if this is in a root. So this is now a root and a root. So that will give us root 6. But the moment this one doesn't have a root, or this does not have a root, you cannot use this to multiply this inside. Instead, you just take the number and put with the root. So this becomes my final answer. This becomes this. This is how you do this. It's very simple. This is how you do this. This is how you do this. Next number, we want to do what we call, let's do 72. Let's do 72. Like I said, bear in mind that we are actually going to produce from this 72 a perfect square number and an irrational number. Don't forget that. Or an odd number. Don't forget that. So what do we do? Like I said, take this 72 somewhere, remove it from the root, first tax, and then divide by the smallest number. The smallest number that can start dividing this now is 2. So let's go. How many 2 can I find in 7? That will give me 3. In 12, that will give me 6. 2 can still go here. I will have 18 here. 2 can still go here. I will have 9. 2 can no longer go here, but 3 can go. You cannot jump from 2 directly to 4. No. If 2 cannot go, you check 3. If 3 cannot go, you check 4. If 4 cannot go, you check 5. If 5 cannot go, you check 6. That's the way you do it. So you cannot just ignore 4, 5, 6 and then jump to 9. No. You are taking it gradually. So this can go in this to give me this. Then 3 can go here, 1. Now from here now, we can now look on how to get out our perfect square and our odd number or our irrational surd. So what do we do now, or irrational number? So observe that if I multiply these 2, obviously I will have 4. So this will give me 4 if you multiply these 2. But if you do this one will give you 6. This is not an odd number. And also this is also not an odd number. So that means that if you check this one very well, check this one, we can also produce another perfect square from here. Check. Yes, these are perfect square. Remember, we have not touched these 2. This is a perfect square number. So when you multiply all of this one, we are supposed to get 72. So from this point, what do? Since we have 2 perfect square number, we are going to make them 1. Make the perfect square number to be 1. Same as if you have multiple odd number, you also make it 1. That is how it is. That's how it is done. Why? Because from the beginning, this number is 1. It's not 2 or 3 or 4. It's just 1. That's 72, root 72. So what do we do here now? We multiply this perfect square, 9, and this. Obviously, this will give us 36. So 36 times 2 will give me 72. So you now see how it works. Getting out from that 72, your perfect square, and also your odd number or your irrational number. Please don't forget, always make the perfect square. If they are multiple, make them 1. Also the odd number, make them 1. Don't forget that. So from here, I am now going to introduce here 36 times 2. That's what I'm introducing here. So you can also break it if you want. You can also find the square root here directly if you want. Any which one you are correct. So from here, I'll break it to be 36 here, and then this here. Well, the square root here is 6. Then this. Remember, I just told you that this cannot multiply this. Reason is because this one is not in a root. Yes, it's not in a root. You only do that where they are both in root, where they are both in sort form. That is root 6, root 2, you can multiply. But if one is outside the root and then one is in a root, the outside one don't have the capacity to multiply the one inside. It doesn't work that way. So what you do, just put the 6 by the side of the root. This becomes 6 root 2. This is how these things works. And I know they are very simple. They are very, very simple. Number 3, let's do 200. Let's do 200. So what's the next thing we'll do if we have 200 here? The next thing we're going to do here is this. I will take out 200 and then use the smallest number that can divide. Use the smallest number that can divide. Let's do it here. So I will start with this. So what can go here obviously is 2. This is giving me 100. 2 can go here is 50. 2 can still go is 25. 2 can no longer go. 3 cannot go. 4 cannot go, but 5 can go. So you use 5. 5 can go here. 5 here. 1. So from this point, what do? We are going to now scout for the perfect square numbers. Obviously, if you start from here, this is 25 now. This is a perfect square. This one too is a perfect square. This 4, a perfect square. So we have this one that doesn't have any partner. You cannot pair this with anything. 2, 2. This is 2. This is 2. Reason because we are talking about square root, square. 2 values. So you make the 2 value 1, 2 value 1. So this cannot be paired to anything. This becomes the odd number. But from here, we have to make this perfect square number to be 1, not 2. So 4 times 25 will give us 100. So here I will have it as this 2. When you multiply this now, I'm having 100 here. Times this 2, obviously that will give us our 200. So what do I do here now? I will now take it out like this, and I'll put 200 times 2. So what do I have? If I split this one, I will have it like this here. So going further, so I will just look for the square root of this. That will give me 10. Then times the root of 2. Bring them together. I'm having 10 root of 2. This is what we talk about when we talk about surd. Now, this is how it is done. Now, going forward as well, please note this. Let's do the relationship between addition, subtraction, and let's see how it works. So let's talk about the relationship between addition and subtraction of surd. Subtraction of surd. Subtraction of surd. So what do we know about that? What do we know about addition and subtraction of surd? All right, so let's talk about addition and subtraction of surd. Let's quickly talk about that. So this is where we combine 2 signs together. So first, we have this on the list. We're asked to simplify this. So we are asked to simplify this. So how do we do this? Now, you are going to observe the sign, plus and minus sign. Also, in this case now, all of the surds are combined together. Please watch me, watch me. First off, what do we do? Now, we are going to find for the roots, this 1, 2, 3 root, we are going to find those numbers that when we break them, it will give us a perfect square and an irrational number or odd number. So let's find for the 3. Let's find it first before we start solving. Now for 48, I'll take my 48 like this. What can go obviously is 2. If I do that, I will have 24 here. 2 can still go, I'll have 12 here. 2 can go, I'll have 6 here. 2 can go, I'll have 3 here. 2 can no longer go here, but 3 can go. So I'll have 1 here. So let's produce our perfect square number. So let's check this. This one will give me a perfect square number, which is 4. This one will give me 4, obviously. Why this one doesn't have any number that you can pair it with? Because it's called square. Square is two numbers. So because this one cannot be paired with any numbers, we now have our perfect square. But the perfect square here, there are 2. So let's break it down. Let's make them 1. So 4 times 4 gives me 16. So 16 times this 3 now will give me 48. So I'll come here. I'll write like this: 3, the root of 16 times 3. So I've gotten the first one. Now plus. Now 75. I have 75 here. And then I'll break it down. Check. Can 2 go in 75? Obviously 2 cannot go. Yes. So let's jump to 3. Like I said, you cannot jump from 2 to 5. No, you go to 3. If 3 cannot go, you go to 4. 4 cannot go, you go to 5. 5 cannot go, you go to 6. 6 cannot go, you go to 7. That's the way you do it, one after the other. So let's check this. This can go here, obviously. I have it as 2 in 15. That will give us 25. 3 can no longer go here anymore. So what do? You use 5. Because 3 cannot go, 4 cannot go. So let's use 5. That will give us 5 and then 5. Obviously, this 2 will give me my perfect square. Why this that cannot be combined with anything now will become my irrational number. So I'll bring this 5 down, this 5, and then I'll have my 25 times 3 here. Now minus, I'll have my 2 here. From this point, what do I know to do from this point? 27 is 9 times 3. But let's go ahead. 2 cannot go, but 3 can go. 3 can go here, 9. 3 can still go here, 9. 3, sorry. And then 3 can go here, 3. So this is 1. So to get my perfect square, I can get it like this. Or you can get it from the down. You can start from down to up or up to down. It's the same thing. So here is 9. This is not combined with anything. So just bring it down. So that will give us 9 times 3. So from here, I'll have my 9 times 3. So this is the number that I have gotten so far. The next thing I'm going to do now is to find the square roots. What's the square root of 16? That's 4. Because I'm having a number outside, this is how you do it. You are going to multiply it with the number outside. Then this one, you leave it inside because that is the irrational number. So this is 5 times this 5 here. Then that will give us 3 minus, that will give us 2. This 3 here will give us this. And this here. So what's the next thing I'm going to do here is that I am now going to multiply the values outside. So this times this now will give me 12. I will get my 12 here. Then root 3 plus 5 times 5. That will give me 25. Then root 3. And here will give me 6 root 3. Now this is how the root work, addition and subtraction works. Now check. Observe that the roots are all the same thing. Watch me. The root are the same thing. So remember what I told you when I was giving you the law. You cannot use the root when you have plus and minus to multiply themselves. No, it doesn't work that way. You only pick one of it. You only do that when it is times. Please don't forget. Whenever you have same roots involving plus and minus, don't multiply or don't add or subtract the root. No, you only pick one of the roots. So from this point, because they're the same root now, I can add this one and remove 6 from it. That is only possible because they're the same roots. Please don't forget that. So from here, this and this will give me 37. 37 minus 1 will give us 31. So I'll pick my 31 here, root 3. That's all. Pick one of the roots. This is how you do addition and subtraction. Next question. This is my number 4. Why this is my number 5? Next question. So I have 180 here, 245 here, 80 here. So let's check this one. Let's check this one. So obviously, see the same thing we are expected to do. Same thing we're expected to do. Now, same thing we're expected to do. The concept is this: you think of a number that it's one of them will be a perfect square, and then the other will be an odd number. And when you multiply them together, will give you 180. Same as this one, same as this one. The root. So that is the way it works. Now let's check it. Let's check it somewhere. Now let's take my 180 somewhere. This is my 180. What can go? Obviously, 2 can go. This is 90. 2 can still go. This is 45. 2 can no longer go, but 3 can go. If 3 can go here, this is 1. In 15 is 5. 3 can still go is 5. 3 can no longer go in 5, but 5 can go in 5. That's 1. So we can produce numbers now. So this is 4, perfect square. This is also a perfect square, but this does not have anything to combine with because we are dealing with square root. That means you have to join 2 numbers together. That's what we are talking of. So here, what do we do now? We have, this one is just 5. So how do we do it now? We have to multiply these 2 to give us 36 times 5. So 36 times 5 will obviously give us 180. So I will come here now and I'll put my 36 times 5 here. So that is how you do it. Minus 5 here. So how do we break 245? So for 245, what can go? 245. So let's check what can go for 245. Now let's check. Obviously, 2 can go in 245, but cannot go in 5. So let's use 3 then. So 3 can go here. 3 can go in 21. That will give us 7. 21, that will give us 7. Here becomes 3, please don't forget. So in 35, can 3 go in 35? To check. So it cannot go. It can go. So let's check another number. So 5 can go. 4 cannot go. 3 cannot go. 2 cannot go, but 5 can go. So 5 can go in this one. That will give us 49. 5 can no longer go in this one, but 7 can go. This is 7. 7 can go here. This is 1. So obviously, this one will give us 49 here times 5. So 49 times 5 will give us 245. So I'll put it as 49 times 5. So plus, for my 80, how do I do my 80 now? I'll take 80 out and I'll divide it by 2. This is 40. 2 can go is 20. 2 can go is 10. 2 can go is 5. 5 can go now 1. So combine this is 4. Combine this is 4. Here does not have any number to combine. Bring it out. So the perfect square here are the same thing. So because they're the same thing now, make them 1. That will give us 16 times 5. So bring this 3 out. So I will have 16 times 5 here. From this point, what do? There is no number outside of this. So the square root of 36 is 6. Then root 5 minus the square root of this one is 7. But we have 5 here. We have a number outside here. So put it like this first. Then root of 5. Remember, we did not find the square root of this one because this will give us decimal. We don't need decimal. We only need those numbers. We only need those numbers that have perfect square, that have whole numbers. Whole numbers. That's what we need. The perfect square number or numbers that will give you a whole number. That's what we need. So here, I have 3 here. This is a perfect square number. So if you do that, I'm having 4. This one will give you decimal. Leave it inside the root. From here, I have 6 here, root of 5 here. This will give us 35. 35 root of 5 plus 12 root of 5. That is it. From this point now, see, they are all having plus and minus, but they are having the same root. So please check this. The root here this minus is for the middle value. So this one and this one are plus. Please observe that they are plus. So you add this one first, add it, or you can say 6 minus this one, and then this minus this one. It's the same thing you will still get. But let me do what I want. So this plus this one now will give us 19, Abi. 18, sorry. 18 root of 5 minus 35 root of 5. So because they're having the same root there, I can go ahead. I can go ahead to do my final answer to become minus 5 minus 17 root 5. So this is how all of these things are solved going forward. They are very simple. Very, very simple. Very simple. Very simple. So from here, I'm going to be giving you a practice question. Please do well to solve and put your answer in the comment section. I will get back to you. Please do well. Please share. Please comment. Please subscribe if you have not done that. So this is a practice question. Your practice question. The practice question, or your work to do, anyone you like to. So please just attempt this for me. So attempt this for me and I will get across to you. See you in the next class. Bye-bye.